Hey Tree Class, let's look at one of these rotation of axes problems. So what we have to figure out is the angle here that we've been rotated by, and then this will basically remove that rotation and get us back to like horizontal and vertical like we're used to seeing before this section. So these XY terms, when you see those, that means you've got a rotated conic. So plugging in, I've got the whole thing graphed right here. So plugging that in, you can see we've got an ellipse and it's been rotated. So what our goal here is to figure out how can we get it back to the same ellipse but horizontal or vertical like we're used to before this section. So again, we need this formula. A is the number that's in front of x squared, B is the number in front of the xy term, and C is the number in front of y squared. So there's where everything goes. The A is 8, the C is positive 4, and the B is negative 4 square root of 3. So when I do my math, 8 minus 4 is 4, so this is negative 1 over the square root of 3. Alright, and if cotangent is equal to that, I always use tangent. Tangent is equal to the reciprocal of that, so the negative square root of 3. Alright, there's the equation I'm going to solve. Because that is tangent, that is putting us in quadrant 4 if I use arctangent. But what's important to remember is when you are using this procedure to come up with this angle of rotation, then if you get a negative, so if that cotangent of 2 theta is negative, and it was, that was negative 1 over the square root of 3 right there, then your angle needs to be between 90 and 180, aka that needs to be quadrant 2. Alright, so that's going to put us, when I do the inverse tangent in just a second, so tangent negative square root of 3 in quadrant 4, again between negative 2 pi over 2 and positive pi over 2. Tangent is equal to negative square root of 3 right there at negative pi over 3. Right, that's in quadrant 4. We need to be in quadrant 2. So we're going to add pi to that, and that's going to put us up here at 2 pi over 3. So that is the angle that 2 theta is equal to. And since theta is 2 pi over 3, 2 theta is 2 pi over 3, theta is 1 pi over 3, just dividing by 2. So there's the angle that we need to rotate by to get this thing back to the origin. Or sorry, back to standard position, along the positive x-axis. Horizontal and vertical, again, like we're used to seeing before this section. Alright, so now we need the cosine of pi over 3 and the sine of pi over 3. Alright, the cosine of pi over 3 is a half, and the sine of pi over 3 is the square root of 3 over 2. So everywhere I see cosine, I'm replacing that with a half. Everywhere I see sine, I'm replacing it with the square root of 3 over 2. Alright, so there is our values that are going to give us the rotation. Now again, this one just goes straight to the next question. That's all you have to get. But I like to show you guys a visual of this. So there is our original. That's the original equation we have. So if I were to make this substitution, meaning if I were to take all this stuff and replace x with it, everywhere I see an x, and I were to take all of this stuff and replace all the y's that I see with it, then that would require a lot of algebra to do that. You're going to plug this in, it's got a difference, you're squaring it, so it's going to be like foiling x times y, this times this. That will require foiling, y squared, squaring that, that'll require foiling. But when you do that and you simplify and expand it, what I've done here is instead of calling it x prime and y prime, I just call it a and b. And when you scroll down, Wolfram Alpha will do that for you, and it'll plug that stuff in for you and simplify it for you. And what happens is we end up with an ellipse, and that's what the ellipse looks like. But I'm going to plot it along with, I'm going to move over just a little bit, and I'm going to plot it here in Desmos. But remember, A is like my new x prime variable, B is like my new y prime variable, and so it simplifies to just x squared and y. There's not an a-b term here. There's not this interaction between the terms that causes these rotations. So I'm going to call it, even though it says a squared, I'm going to call it x squared because that's, again, what it represents. Let me change this color. And then a 5, and then b is like the new y, equal to 0. And what we end up with is that ellipse that we started with back in that horizontal position. All right, and then think about the angle that we calculated. What angle did we get here? We got pi over 3. So if I did y equals, remember, tangent is the slope of the line that connects the point in the middle, the circle to a point on the unit circle. So if I did tangent pi over 3 times x, I'll get a line that's slope goes through the origin and through the angle of inclination there from the x-axis up to there is pi over 3. That's what tangent does. It'll create a slope. This is like slope. Remember, mx. And this has a slope of 60 degrees, or pi over 3 radians. And that's rotating us from standard position up to here. We have literally rotated this ellipse by pi over 3 radians. And with this transformation that we came up with right here, it's basically like we're rotating back down to the standard position, that positive x axis.